Hey everyone, welcome to another video. In this video, we're going to be solving 6 separate FRQ questions. So you can see the lesson title on each one of these questions from Unit 2, Unit 3, and Unit 4. So let's get started. The first question, they said, consider the closed curve in the xy plane given by x squared plus 2x plus y to the power of 4 plus 4y is equal to 5. Part A. Show that dy over dx is minus x plus 1 over 2y cubed plus 1. So, for part A, basically we need to find the implicit differentiation for this equation. So it's going to be 2x plus 2 plus 4y cubed 3 dy over dx plus 4 dy over dx equals 0. Now, you have to isolate the dy over the dx by itself and move everything else to the other side. So it is going to be dy over dx as a common factor, open brackets. We got 4y cubed plus 4 close brackets equals negative 2x negative 2. Now, once we divide by 4y cubed plus 3, or 4y cubed plus 4, sorry, over 4y cubed plus 4, we will get dy over dx equals. Now, if you take negative 2 as a common factor in the numerator, it will be x plus 1. And if you take 4 as a common factor in the denominator, it will be y cubed plus 1. So now just simplify negative 2, it will become negative 1. 4 divided by 2 will be 2. So the final answer will be the same as the question suggested. 2y cubed plus 1. This is it for number 1, part A. Now part B. In part B, they said find the equation for the line tangent to the curve at the point negative 2, 1. So x and y in this case is negative 2, 1. And we know that the equation of a tangent is basically y minus, let's say this is point A. So y minus y of point A equals dy over dx at point A. So you can write it like this. So just for you to remind yourself that I need to replace x and y with the coordinates of A, x minus x of A. So in this case over here, y minus, what is y of A over here? It's basically 1 equals dy over dx at point A. So now I need to find dy over dx at, you can make a line like this, negative 2, 1. So this means, this symbol means that you're going to replace x and y with negative 2 and 1. So it is going to be negative 2 plus 1 over 2, 1 to the power of 3 plus 1. So negative 2 plus 1 is going to be negative 1. Negative outside, it's going to be positive 1 over 1 plus 1 is going to be 2 times 2, which is 4. So we got dy over dx as 1 over 4. X minus 2, which is x plus 2. So this over here, so y equals 1 over 4, x plus 2 plus 1 is going to be the equation of the tangent. Now, part C. Find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. Now, before we get into this question, when we say that a tangent is vertical, we mean that dy over dx is approaching infinity, plus or minus infinity, it doesn't matter. Because if you take any regular linear equation, let's say this linear equation, it has a slope of a, right? Now, if a gets higher, it could be steeper, and then steeper, and then steeper. So we say that as the slope of this line is tending to infinity, that means that the tangent line is getting closer to being vertical. So first of all, let's write dy over dx. dy over dx is basically, as they suggested, minus x plus 1 over 2y cubed plus 1. Now, in order for this to be infinity, the numerator should not be 0 and the denominator should be 0. So over here, x shouldn't be negative 1 and y cubed plus 1 should be equal to 0, which means that y cubed is equal to negative 1, which means that y should be negative 1. Now, if y is equal to negative 1, that means I need to replace y is equal to negative 1 in the original equation. Why? Why do we need to do that? Because they want us to find the coordinates of these 2 points. And the meaning of the word coordinates, it means they want the x and they want the y. So replacing y is equal to negative 1, you're going to get x squared plus 2x plus 1 minus 4 equals to 5. So rearrange this quadratic equation. So x squared plus 2x, 1 minus 4 is negative 3. Negative 3, negative 5 is going to be negative 8 equals to 0. This is going to result in two answers. You can use multiply 3 on your calculators. It will be x is equal to negative 4 or x2 equals to 2. So the two coordinates are going to be minus 4 minus 1 or 2 minus 1. This is it for part C. Now part D, what did they say for part D? Is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? Explain your reasoning. So there are two pieces of information over here. The first piece of information, they said that you gotta have a horizontal tangent. A horizontal tangent, it means that dy over dx is basically equal to 0. That's the first thing that you need to understand. The second thing you need to understand is the fact that they said it intersects the x-axis. And in intersection with the x-axis, it means that y is equal to 0. So let's first of all work with this piece of information. dy over dx is equal to 0. If it's equal to 0, it means the numerator is equal to 0, which means that this should be equal to 0, which means that x should be negative 1. Now, if x is equal to negative 1, now I can replace it in the function so I can verify if the y is equal to 0. So once you replace x with negative 1, you're going to get negative 1 to the power of 2 plus 2 times negative 1 plus, what did we say about the y? The y, we want to see if it's indeed equal to 0. So I need to replace it with 0 over here and over here. And if it was equal to 5, that means it is indeed equal to 0. If not, then it does not exist. So plus 0 to the power of 4 plus 4 times 0. What is this? These two are going to be zeros, and negative 1 to the power of 2 is going to be 1. 2 times negative 1 is negative 2, and the answer is going to be negative 1, which is different from 5. So this point over here does not, the curve does not have a horizontal tangent where it intersects the x-axis. So once again, let's recap what we did for part D. They said they wanted a horizontal tangent, which means that dy over dx is equal to 0. After we see the condition for dy over dx is equal to 0, we can see that x should be negative 1. Now, since they said that it should also intersect the the x-axis, the y should also be 0. So by replacing x with negative 1 and replacing y with 0 in the original equation, we can find that there is no equality. Therefore, there is no horizontal tangent at that point where it crosses the x-axis. Now, moving on to this question, we got the twice differentiable function f is defined for all real numbers and satisfies the following conditions. F of 0 is equal to 2, f prime of 0 is equal to negative 4, f double prime of 0 is equal to 3. The first question. The function g is given by g of x is equal to exponential to the power of ax plus f of x for all real numbers, where a is a constant. Find g prime of 0 and g double prime of 0 in terms of A. Show the work that leads to your answers. So, part A. So in part A, we want to find g prime of 0. So g prime of x, first of all, since this is just like an addition of functions, we just do the derivative for this part and the derivative for this part. So it's going to be a e to the power of ax plus f prime of x, because f prime of x is the derivative of f of x. Therefore, g prime of 0 is going to be a e to the power of a times 0 plus f prime of 0. So f prime of 0 over here, it's already given from the question. It says that f prime of 0 is equal to negative 4. So, and e to the power of 0 is basically 1. So it's just a negative 4. So this is it for g prime of 0. Now we need to find g double prime of 0. Now g double prime of 0, we need to find g double prime of x first. Since a is a constant, that means that the derivative again is going to be a squared e to the power of ax. Or in other words, if you want me to explain more, e to the power of ax again is going to be a e to the power of ax plus f double prime of x, which in turn will become a squared e to the power of ax plus f double prime of x. Therefore, g double prime of 0 is going to be e to the power of 0 is going to be 1, so it's going to be a squared, and f double prime of 0 is basically 3, so a squared plus 3. Part B. The function h, which is given by h of x as cosine kx f of x. So they're multiplying each other, which is the main indicator for product rule. They told me that k is a constant. They want me to find h prime of x and write an equation for the line tangent to the graph of h at x is equal to 0. So first things first, let's find h prime of x. So h prime of x, I need to apply my product rule over here. So this is going to be my u, this is going to be my v. So h prime of x is going to be of the form u prime v plus uv prime. Therefore, it's going to be, first of all, the derivative of cosine kx using chain rule, it's going to be minus k sine kx. Remember that you take the derivative of what's inside out. So the derivative of kx is going to be k, and the derivative of cosine is going to be negative sine. And then this is u prime, v plus u, v prime, which is f prime of x. Now, we need to apply h prime of x at x is equal to 0 in order for us to find the equation of the tangent. So h prime of 0 is going to be minus k sine k times 0 is just 0, f of 0 plus cosine k times 0 is 0, f prime of 0. So sine 0 is going to be simply 0, so all of this is going to be 0, and cosine 0 is 1, which is basically just f prime of 0. So 1 times f prime of 0, which is going to be negative 4. So now the equation of the tangent is going to be y minus h of 0 equals negative 4 x minus 0. So h of 0, just next to it, h of 0 is just the main equation over here, which is going to be cosine 0 f of 0. Cosine 0 is basically 1, so f of 0 is just going to be 2. So it is going to be y minus 2 equals negative 4x, or basically negative 4x positive 2. This is it for this question. All right, now we got this implicit function. It is called 2y cubed plus 6x squared y minus 12x squared plus 6y is equal to 1. First question, very straight to the point, show that dy over dx is the following. So part A. So first of all, differentiate implicitly. So 2y cubed, it's going to be 6y squared dy over dx. In case you don't know, the 3 goes down and 3 multiplied by 2 is going to be 6. And then the new power for y is going to be subtracted by 1. So 3 minus 1 is going to be 2. And then you multiply by dy over dx because y is a function. It's not a variable. So you need to use chain rule. Plus, now 6x squared y, you got to use product rule for that. So open brackets. This is going to take the place of u, and this is going to take the place of v. So u prime, it's going to be 12x, v is going to be y, plus 6x squared dy over dx, minus 24x plus 6 dy over dx equals to 0. Okay. Now I just need to isolate dy over dx. So if you take dy over dx as a common factor, you're going to be left with 6y squared plus 6x squared plus 6. And on the other side, you're going to have 24x minus 12xy. So you're moving this and you're moving this to the other side, and you are basically just get these as a common factor over here. So now you divide by that common factor. So then you will have dy over dx equals, you can take 12 as a common factor over here. So 12 into 2x minus xy over, now take 6 as a common factor, y squared plus x squared plus 1. 12 divided by 6 over here, they're going to be equal to 2. So it's going to be 2 into 2x minus xy over y squared plus x squared plus 1. Now if you compare this with this, you would notice that the numerator, they didn't have it factored. So let's just distribute it again. So it will become 4x minus 2xy, as the question suggests. And the denominator, they just swap the places of y and x, which is no problem at all. X squared plus y squared plus 1. So this is it for part A. Now part B. What did they ask us for part B? They said, write an equation of each horizontal tangent line to the curve. So remember, horizontal tangent, it means that the numerator is equal to 0 because we want dy over dx to be equal to 0. So horizontal tangent, it means dy over dx equals to 0. Horizontal tangent line. Which means that 4x minus 2xy over x squared plus y squared plus 1 equals to 0, which means that 4x minus 2xy equals to 0. Now if you take 2x as a common factor over here, you're going to get 2x into 2 minus y equals to 0. So according to the zero product property, which says that if you have two values multiplying each other and the answer is 0, that definitely means one of the values is 0. So either 2x is going to be 0, which is x is equal to 0, or 2 minus y is equal to 0, which means y is equal to 2. So if x is equal to 0, let's replace it in the original equation over here. On the top, we will get 2y cubed plus 6y equals to 1. if you take everything on one side, you will get a cubic equation. When you solve this cubic equation, like using a calculator, multiply 4, you're gonna get y is equal to 0.165. So we got y is equal to 0.165 as the horizontal tangent in this case. Now, if y is equal to 2, and you replace it in the function above, you're gonna get 2 to the power of 3 plus 6x squared times 2 minus 12x squared plus 6 times 2 equals to 1. So 2 to the power of 3 is going to be 8 times 2, which is 16. 12x squared minus 12x squared plus 12 equals to 1. This and this will go away. 16 plus 12 is going to be 28 is equal to 1, which is impossible. So y is equal to 2 will be rejected because 2 dots. So then this will be the explanation for it. So the only equation that we got over here as a horizontal tangent is y equals 0.165. Okay, part C. Let me write it over here. So part C, they said the line through the origin with the slope of -1 is tangent to the curve at point P. Find the x and y coordinates of point P. So first of all, they said the line through the origin, and we know that every single linear equation that passes through the origin is of equation y is equal to mx, not mx plus b, because there's no y-intercept anymore. The y-intercept is 0, like there's no value to it. And they already said that the slope of this line is basically -1. So I know for sure that my equation is going to be -x. Y is equal to -x. So this y is equal to -x. It is intersecting the curve, the one that I have over here. So what we are going to do over here, we already have the relationship between y and x in this case. So in the place of every single y you see in front of you in this equation over here, we're going to replace it with -x. So it will become 2 -x to the power of 3. Let me just scroll up a little bit. Plus 6 6x squared -x -12x squared plus 6 -x equals to 1. So over here, basically we just need to solve this normally. This will become -2x cubed -6x squared -12x squared -6x is equal to 1, which will give you -8x cubed -12x squared -6x -1 equals to 0. You can use multiply 4 for this situation, and then you will get that x is equal to -12. Now, if x is equal to -12, that means that y is the counter for it, because if y is equal to -x and x is equal to -12, that means y is going to be equal to half. And that's basically it. Okay? And this is it for the second question. Now we got this question right over here. This says that we got an equation which is y squared is equal to 2 plus xy. And what do they want us to find? dy over dx as the first question. So what we are going to do over here, also implicit differentiation, 2y dy over dx is equal to 0 plus product rule, u prime, which is 1, because this is going to be my u, this is going to be my v. u prime v plus u v prime. So isolate the dy over dx. Let's take this piece to that side. So 2y dy over dx minus x dy over dx is equal to y. Take dy over dx as a common factor. We will have 2y minus x equals 2y. And then divide by 2y minus x for both sides. We're going to get dy over dx equals y over 2y minus x. That is the first question. Now, part B. Find all points xy on the curve where the line tangent to the curve has the slope 1 over 2. So the value of the slope is equal to 1 over 2, which means that the value of dy over dx is equal to 1 over 2. So we need to start by saying that dy over dx is 1 over 2. So y over 2y minus x is equal to 1 over 2. Cross multiplication. We will get 2y equals 2y minus x. 2 minus 2y, it's going to be 0 because if you take it to that side, so x is going to be equal to 0. Now, if x is equal to 0, let's replace it back in the main equation over here. If x is equal to 0, then we will get y squared equals 2 plus 0. So basically y squared is equal to 2, which means that y is equal to plus or minus square root of 2. So the 2 points is basically 0, square root of 2, or 0, negative square root of 2. Now, that's it for part B. Now part C. Show that there are no points xy on the curve where the line tangent to the curve is horizontal. So they're telling me that dy over dx can never be 0. Let's see. So dy over dx, let's say if dy over dx is equal to 0, that means that y over 2y minus x is equal to 0, which means that y is 0. But if y is equal to 0, I'm going to replace y with 0 in the main equation to see that if I will get an equality or something, that means 0 squared is equal to 2 plus x times 0, which is 0 is equal to 2, which is impossible. So there's no horizontal tangent line. Now, part D. They said, let x and y be functions of time that are related by the equation y squared is equal to 2 plus xy. At time t is equal to 5, the value of y is 3 and dy over dt is equal to 6. Find the value of dx over dt at time t is equal to 5. This is a question coming from Unit 4. I believe, yeah, it does have Unit 4 in this question. So the first thing that you got to do, you got to implicit differentiate everything. So basically all you got to do over here is differentiate this piece over here. So 2y dy over dt is equal to 0 plus product rule, which is going to be u prime dx over dt times y plus x dy over dt, and that's it. Notice over here that instead of doing dx, like instead of differentiating x as 1 as I did before, they said that x is a function of time right now. So now x is a function. So I cannot treat it as a variable anymore. I need to treat it as a function. Therefore, that's why I wrote it as dx over dt. Now, then I continue over here. I know my dy over dt. They want me to find the value of dx over dt. But there's a problem, like a very minor problem over here. I have an x over here, and I don't know what's the x. However, I can find it out because from this main equation over here, when y is equal to 3, replacing y is equal to 3, we're going to get 3 to the power of 2 is equal to 2 plus x times 3, which is going to be 9 is equal to 2 plus 3x, which is going to be 7 equals to 3x, which means that x is 7 over 3. So now problem is solved. Now replacing every single variable with their proper value, y is 3, so 2 times 3. What is dy over dt? It's basically 6 equals to 0 plus dx over dt is the value that I need to find. Y again is basically 3 and x is 7 over 3 and dy over dt is basically 6. So now 2 times 3 times 6 is going to be 36 equals 3 dx over dt. 7 over 3 times 6, it is going to be 14. Working this out, you are going to get dx over dt is equal to 22 over 3. Okay. Next question. Okay. Now this question is a very nice question. It's basically related rates, 4.4 and 4.5. It says ship A is traveling due west toward Lighthouse Rock at a speed of 15 kilometers per hour. Ship B is traveling north from the lighthouse at a speed of 10 kilometers per hour. Let x be the distance between ship A and the lighthouse at time t, and let y be the distance between the ship and the lighthouse at time t as shown in the figure above. Find the distance in kilometers between ship A and ship B when x is equal to 4 and y is equal to 3 kilometers. So, as you can see over here, we have a right triangle, and how do we find the hypotenuse of a right triangle? It's basically Pythagorean theorem. So, since they use the letters x and y, I'm going to use the hypotenuse as z. So, z squared is equal to x squared plus y squared. So, z squared is equal to 4 to the power of 2 plus 3 to the power of 2. And this is going to be 16 plus 9, which is going to be 25. So z is going to be equal to 5 kilometers. That's part A. Part B. Find the rate of change of the distance between the two ships when x is equal to 4 and y is equal to 3. So now using the Pythagorean theorem, which is z squared is equal to x squared plus y squared, we're going to treat this formula as an implicit equation. And we need to differentiate it. So this is going to be 2z dz over dt, because everything is changing with time over here. 2x dx over dt plus 2y dy over dt. Now, before we continue, let's just stop for a minute and realize that every single variable over here is changing with time, because as ship B is moving to the north, the y is changing. As ship A is moving towards the east, right? Traveling to west. Ship A is traveling to west, whatever it is, that means x is changing with time. And since these two variables are changing, it means that the hypotenuse itself is changing. And I know that west in this is in this direction, but ship A is going to this direction, so, but it doesn't matter, whatever it is. So 2z dz over dt, 2x dx over dt, 2y dy over dt. Now, all I got to do over here is just plug in everything that I have. So basically, all I know is that ship B is traveling due north at a speed of 10 kilometers per hour. So ship B is over here, which is associated with y. So that means dy over dt is going to be 10. So dy over dt is going to be equals to 10 kilometers per hour. Now, the second ship, which is ship A, is it going? Yeah. They said that it's traveling due west at a speed of 15 kilometers per hour. Now, here's what's going to happen over here. dx over dt is going west, so it's going to the negative direction. So we're going to assume that it's going at negative 15 kilometers per hour. Because if the positive direction is basically the east and north is plus, that means west is negative and south is negative. So z is basically 5. dz over dt equals 2. What is x again? 4. And dx is negative 15. Plus 2. What is y? Y is basically 3. And dy is basically 10 over. Okay, this is it so far. We can simplify first of all by crossing out every single 2. And then we can divide everything by 5. So dz over dt is going to be 4 times minus 15 plus 3 times 10, which is 30 over 5. Now 4 times minus 15 is going to be minus 60 plus 30 over 5. Minus 60 plus 30, it's going to be minus 30 over 5, which is going to be minus 6 kilometers per hour. Okay, now part C.